Awesome. Thanks everyone for joining, and let's kind of get started. So today I'm excited to talk with Nathan Benaich about the state of AI. Nathan's the founder and general partner of Air Street Capital, a venture capital firm investing in early stage AI first technology and life science companies. And Nathan's the co-author of the annual State of AI report and the newsletter Your Guide to AI. To get started, Nathan, what was your motivation for putting this report together, and how did you get started?
Yeah, thanks so much for having me, Elliot. Really looking forward to the discussion. So a couple of years ago, Ian Hogarth and I kind of met up in a cafe, and we'd both been monitoring basically the state of AI over several years. Him as an undergrad doing machine learning several years ago, and then through his entrepreneurial experience at Songkick, and then as an angel investor. And on my side, doing grad school work in more computational bio and using ML techniques in genetics research. And then laterally making investments in early stage startups, and then meeting a large kind of proportion of the ecosystem. And we basically thought that we're in this sort of unique vantage point where we interface with small companies, big companies, government policymakers, and investors, which gives us a pretty cool vantage point over where the puck is going in machine learning. And we felt it would basically just be like a fun project to kind of cobble together what we thought were the most interesting trends, sort of like a mixtape, if you will, and then just put it online as a public good. And one thing kind of led to another, and a few people really liked it the first year around, and we tried to get a little bit more sophisticated and add some more structure around it. And it's really there as a public good for anybody to consume, so we can try and level up the conversation about this pretty exciting technique and field, but one with tons of noise.
No, I've always really appreciated reading it, and I really appreciate the kind of data-driven first analysis that you guys put into it. From this year's report, you make about 8 predictions for about the next 12 months, including transformers replacing a lot of the work with recurrent networks, consolidating in the AI semiconductor market, kind of small hybrid models matching state-of-the-art, and new frameworks like JAX developing. And also went over 8 predictions from last year's report. When you look back at the predictions from last year and how they came to pass or didn't, what was the most surprising for you?
I think maybe the most surprising one was just how widespread the expansion of transformers from NLP into almost every other machine learning task has been. We predicted that it would be applied in computer vision, and we saw that with the vision transformer setting new benchmarks on ImageNet, but we didn't necessarily think that it would expand into chemistry, like reaction prediction of molecule A plus molecule B equals 50% of molecule C and 40% of molecule D, etc. And we had an idea that biology was going through its AI moment, as was tracked by a number of papers and interest and kind of early findings, but we didn't necessarily think that like such a large swath of biology and drug discovery would also be applicable to transformers. So I think that's like probably the sort of biggest prediction, or the biggest kind of surprise, the widespread nature over transformers.
And out of the predictions for this coming year, what do you think is the most important or will have the biggest impact in the state of AI?
I mean, we spent a lot of time in this report kind of digging into the semiconductor supply chain, and we noticed that a lot of the mainstream news sort of came online to realizing how complex and interweaved the supply chain is, ranging from procurement of materials to processing those materials to the machines that etch very small patterns on silicon that is used by TSMC and other businesses, and how these supply chains are incredibly tight knit and benefited a lot from globalization and specialization in different countries. And now we see almost like a reversion over towards more onshoring and the tensions that this that is created on a global scale, and supply chain shortages and things like that is a pretty major trend that we think is going to accelerate in the next 12 months, and is one of the reasons why we predicted that ASML, business that I think many people hadn't heard of before that makes these extreme ultraviolet light machines to etch patterns on silicon will grow significantly in market cap, kind of driven by these kinds of geopolitical tailwinds.
And for, I guess, for you personally, which is the one that you'd be most excited about seeing come true?
I mean, I'm kind of a science nerd to be honest, so like I'm really looking forward to, even more fundamental science problems getting solved with machine learning, and we made one prediction that DeepMind would make another breakthrough in the physical sciences, and we had like a little internal debate on our group chat as to whether mathematics is a physical science or not a physical science, but there was a cool Nature paper on the cover just a few weeks ago. Actually, a friend from grad school worked on where they helped mathematicians solve complex knot problems. So I'm kind of excited to sort of seeing machine learning go into physical sciences like space or quantum or things like this.
Well, as a recovering mathematician, I'll definitely say that I appreciate the work that AI is doing there. But kind of going to transformers, like you guys were definitely right that 2021 was the year when transformers really saw breakout success in domains outside of NLP. Can you give some examples of some of those really exciting use cases and like what areas you see it expanding into in the future?
Yeah, so we mentioned the vision transformer on ImageNet, but we also saw brand new performance benchmarks on speech recognition with the lowest word error rate getting hit using transformers. We also highlighted more work in computer vision focused around 3D point cloud classification and segmentation. And in particular, like we have a big section on AI first approaches to biology, and the two kind of coolest applications that I found was both involving NLP sort of transformer models, where in the first instance there was a group at Salesforce Research that made use of these same models that would be applicable to translating a sentence from one language to another or predicting the next token in a sentence, and using that on a large body of proteins. And from that, basically figuring out the sort of language of proteins so that you can basically ask the model to generate a sequence with a particular function. And the coolest bit of all of that is that you can get this model to generate a protein that has never existed in nature and has kind of de novo properties that are of sort of industrial importance and interest. And the second one is sort of relevant more towards the pandemic. And there was a group at MIT that used, again, similar NLP models to effectively learn the grammar of the spike protein on the virus to figure out what kinds of mutations might occur in the spike protein that would confer a higher fitness, as is expressed by a virus that's more able to bind to the receptor in the human body or less. And then you can kind of use this or kind of roll forward what you might do with this kind of approach, which could include things like generating more proactively these mRNA vaccines and thinking about sort of an AI-first approach towards mRNA vaccine design.
That's definitely exciting. I'm personally excited about the fact that as all these problems are tackled by the same type of framework, it becomes easier and easier to do multimodal learning and incorporate insights from all these different input streams at the same time.
Yeah, it's really remarkable, like the transferability of these models in different domains. And we got asked this question of like, how is it that a research group at Salesforce that makes enterprise software is able to, like have a big impact in a field that presumably they have kind of no direct experience in. And I think the fact that that's possible is sort of a hat tip towards the generalizability of the representations that these models are learning.
Well, and now that they've made this jump from NLP to computer vision and kind of all these different use cases, where do you feel like they can make the biggest impact on industry?
So one of the sections that in the report that sort of expresses this is there's so many more companies nowadays that are implementing these transformer models for various like natural language tasks. So obviously you see like the rise of Hugging Face, but also Cohere, and several other businesses that are productizing these large language models through APIs. I think the surface area of domain applications, everything from legal contract review to next word predictions or like a better Grammarly, to translation of documents, etc. So I think it's just about making like all those applications that were pretty good, like good enough that now customers are willing to pay for them and depend on them. And perhaps going into, even more kind of vertical domains, like, understanding, medical records and understanding kind of minutiae of basically like legalese that is not necessarily present on Wikipedia. So I think it's going to be quite a bit of work going on there too.
Yeah. So breaking away from transformers, as exciting as they are, like a lot has been made of the advances in like unsupervised learning, and the enterprise value always seems to be just around the corner. And some of the exciting cases are things like data discovery and bootstrapping for transfer learning and things like that. Where do different forms of learning play a role in industry? Should every team start with weak learning, or should it be a bit more nuanced than that?
Yeah. I feel like the general advice is like start with the simplest approach possible to just even figure out whether like the task you're trying to solve is like machine learnable. I think there's this challenge where academia is publishing amazing state-of-the-art results with like super sexy models, and then you have this dichotomy of what the reality is in industry, and to some degree, which models actually make commercial sense to run and maintain, etc. So always start with the simplest, and then I think that like starting with something simple helps you really understand the domain and the problem that you're working on, so that you can understand like which areas might you go into next. Is it more complex architectures? Is it better data? Is it maybe an ensemble of models that can eke out the performance you need to solve whatever business problem you have? So that's usually kind of what I think about. And certainly for data discovery, unsupervised learning is super valuable, and we see that a lot with our computer vision companies.
And like on that train, isn't it easier to start with a weak learning approach or some of these semi-supervised learnings before going in and creating massive labeling pipelines and spinning up all those things if you don't have data already, or if you're just trying to validate an idea?
Yeah, it could be. I think it kind of depends on the sort of business you are. Like if you're sort of an AI first company, it's going to make sense that you start with the data platform, like really figure out your annotation schema, really figure out your task and what kind of models you can use, et cetera, so that you're building up for success longer term. But if you're a business that's more kind of non-machine learning software and you're trying to iterate quickly on a feature and test it out, then you might find a pre-trained model on GitHub or something, or you might be able to use a more weakly supervised model, like using these labeling functions, for example, to sort of get somewhere a bit faster. So I think it sort of depends what flavor of a business you are, what kind of resources you have, and sort of what you're building long term. Like, is machine learning a core competency to you? Does it define your product, or is it like a nice to have?
Awesome. So in your report, you state that with increasing power and availability of models, gains from model improvements have become kind of marginal. And in this context, the ML community is increasingly aware of the importance of better data and more generally better MLOps to build reliable products.
Yeah.
What do you see as the place of MLOps tooling as valuable, and like what should people be thinking about there?
Yeah, I mean, there's as you mentioned, there's like a real resurgence in interest and focus on data being a differentiator as opposed to models. I think that's one of also the main differences between academia and industry, and it's a function of issues like models not being great when there's data drift, issues of potentially bias like creeping in, and so that's ultimately like driving people's focus to, okay, like how am I collecting, how am I annotating data, and do I have proper checks and balances in place to make sure that my models are learning something useful, and as my customer behavior changes or I onboard new kinds of customers, then my models are like robust to those sorts of changes. And so I think like the cool thing I've seen certainly in the investing landscape is, whereas a couple of years ago, call it like 2015, the sort of early generation of deep learning businesses that started, there was no SaaS offering for a labeling platform, and so these companies had to sort of hack something together with internal resource. And then over time, as some of those businesses became bigger and like had real ARR generating products, then sort of realized like resource is scarce and it doesn't necessarily make sense to build and manage these internal tools anymore. And then as more and more vision companies came into the market, they then created, they amplified that pain basically to the point that some engineers were like, well, maybe we can build a SaaS product for this. So I think it's the fact that now data platforms have emerged as a SaaS offering and are sort of no longer considered to be a competitive advantage, but almost like a table stakes to be competitive, is a sign of the maturity of these companies and of the market in general. And so now it's sort of like almost becomes a de facto choice about, okay, I'm going to start a vision company. Like, I need to buy a data platform. Which one am I going to buy? And it sort of depends on what your use case is and, certain developer preferences, et cetera.
Yeah. So following on from that, like Chris Ray group really launched a data-centric AI repo on GitHub to aggregate resources, entering Deep Learning AI is organizing a data-centric AI competition where people are asked, given a fixed model, to modify the data to get the best performance. And you can even see it extending to this year's NeurIPS conference going on right now, where we have multiple different venues for people to highlight their work only on the data sets and the data-centric AI. Are those viewpoints on data-first modeling just an academic angle, or is this becoming pervasive in industry as well?
I think it's certainly being pervasive in industry, and I think certainly Chris Ray's group is one of the like extremely industrial focused labs where they really take problems that exist in the real world and do research on that. So he's extremely pragmatic in that regard, and Andrew Ng is probably somewhat similar. So I think this trend is certainly here to stay. I think it's just a question of like what we call this. These kind of monikers are changing all the time, and is it a data platform? Is it data centric? Is it model centric? We don't really know yet, but the trend is definitely here to stay. And in the report, we profile a few kind of trends in that regard, like active benchmarking, to make sure that basically models can see more real world scenarios, and where those benchmarks are constantly updated by human users. Also data sets that kind of tackle distribution shifts, as we kind of discussed, and kind of finally this notion of under specification, which is also another kind of problem that manifests in industry, where basically models can perform slightly differently depending on how you initialize them, which is like slightly scary. So yeah.
Do you feel like this approach will pay more dividends for academia or for industry in I guess different way? Do you think this will help kind of close the gap that we've seen between how ML works in industry and academia?
Yeah, I think it's going to create like a faster sort of on-ramp between folks who graduate from academia and then want to go into industry, and how quickly can they become effective, because we're sort of teaching industrial relevant principles in the academic setting. And I also think like it's largely kind of overdue in a way, because whereas you guys at Scale, like you generate all these amazing high quality data sets, and a lot of people in academia are still like working on kiddie data sets that are like incredibly pixelated and generated I don't know how many years ago. And so I think there's like this kind of interplay between bigger companies and startups that can generate high quality data sets, and then we can all agree that data centric AI is the right way to go, and then there can be a lot of cross pollination of these data sets, so that academics when they're trained and future engineers when they're trained are kind of working on the same subject, on the same substance, and have more like industrial relevant skill sets.
So kind of going to some of the stuff you were talking about earlier on the semiconductors and why it's so important. Like 2021 was really the year of novel AI semiconductors and supply chain chaos. Also, we're seeing governments across the world turn their attention and money towards the semiconductor production problem. Historically, once a business or region has kind of lost its lead, it's almost impossible to catch up. And the US kind of transferred a lot of that knowledge and industry to Japan more than 30 years ago with memory and things like that. How realistic is it for the AI industry to move away from like a single highly influential region for production?
I think that's like $1 trillion question, literally based on like the investments that big companies are making. And we looked at again like the kind of concentration in this industry, and in particular like some reports that looked at how expensive it would be to replicate like the value chain in Europe and in the United States. And was something like, despite the US and Europe kind of earmarking 200 billion to sort of onshore back semiconductor capabilities, achieving sovereignty over the whole value chain would cost over $1 trillion. And so that's almost 6 times the combined R&D investment and capital expenditure of the entire semiconductor value chain in 2019. So it's an incredibly steep uphill battle. In a way, though, it's if you're a policymaker, it's almost something that you have to do, I think, just based on the way geopolitics is working out. But I think it's about maybe being tactical over what parts of the value chain are you actually going to try and onshore, because things like minerals are maybe a lot more difficult for certain countries to onshore because they just physically don't exist in their country. But capabilities like lithography, maybe not for the super leading edge, minuscule nanometer processes, but for the more kind of run-of-the-mill chips that you get in cars and things like this, we can have a better shot of having domestic players.
And does it feel like those kind of really core steps in the value chain are possible for people to bring up? Are we seeing investment being made in those areas?
There's a lot of commitments getting made, and then certain domestic players that like in Germany that are kind of stepping up to the plate and saying, we're going to build capability. I mean, of course, like Intel has been making a lot of positive signals and commitments in that regard, but I think it's just this industry just takes a lot of time to spin up, and a ton of highly competent individuals, of which there are not very many. So I'm like very, very, very cautiously optimistic that we can actually make a real dent in this if we focus on the leading edge processes, and more bullish on the less leading edge processes, which don't require kind of TSMC level expertise to affect.
And how has the recent kind of uncertainty in the silicon market affected companies with respect to their AI investments and what bets they're choosing to place?
Well, it's certainly been the benefactors, basically been Nvidia, I think, over the last 12 months. It's just amazing to see that ever since they announced the acquisition of Arm in September last year for 40 some billion, the market cap of Nvidia has just doubled. And so the acquisition is almost, it's definitely free basically at this point. So, but companies, I think, are increasingly, still turning to cloud offerings as opposed to buying their own racks and managing their own racks. But beneficiaries still like Nvidia, and then various cloud service providers like AWS and Google. And then of course on the gov side and kind of research side, it's where more of the specialized semiconductor companies have made some headway.
Awesome. So autonomous driving and recommendation systems are some of the most pervasive and arguably some of the most effective forms of AI right now. And one thing in common is that developing those systems and those models relies on large investments in MLOps and ML infrastructure. And Tesla's even gone so far as helping popularize the idea of operation vacation and having infrastructure play a seminal role in creating the AI advancements itself. For people that want to start working with those ideas, what's the order of investments that they should think about? What should they do now versus what's important to think about more later on?
Yeah. So I generally think number one is sort of problem scoping and problem framing, so that you understand what task you're trying to solve, what does good look like, what does bad look like, is there a good way of expressing this? Number two, I would say then it's basically data collection and annotation, as we kind of discussed, and trying to pull from best-in-class models that are publicly available. Then if it looks like there's some success there, then I think investing more in data platform, model training, and evaluation. And then once the business case is even proven there, then I think you can start moving towards the monitoring and observability kind of problem set, really, which is bubbling a lot, and lots of venture funding is going into this direction. But I think the companies that really feel the pain are ones that have large scale deployments in potentially high stakes environments, and where like the pain of mistakes is either felt by customers being unhappy or the business jeopardizing certain revenue opportunities. I think like investing in observability before you have a product in the market or before you have large scale is like probably not the best use of money, at least in my opinion.
And how customizes MLOps infrastructure to the specific problem that people are trying to take on?
It's a good question. I don't envy like engineering leaders kind of making design decisions and infrastructure decisions nowadays, because the number of new companies and solutions and open source that come onto the market like every like 6 months or something is beyond what you'd want if you're making a long-term decision and you want like stable foundations, almost like you're building a house on sand. So it's I don't know. I guess it's hard. It's like my kind of sense. And the other kind of interesting thing that comes out of that is then, more companies are opting towards modular solutions, in my experience, what I've seen, versus like fully end-to-end solutions, just so that they can, best take advantage of new components that come online, or open source tools that come online, or just like internal tools that they'd rather patch up. Instead of making that huge commitment of we're going to build everything on this platform, and it might not be the best for certain parts.
Yeah, modularity and like API driven first is definitely some good properties. Like, what are, in your opinion, some of the other properties that are really valuable to have in an MLOps platform?
Portability, being able to run in various cloud environments. I think the other thing that would be good is that it's not just a tool that engineers can use, but that data analysts can use, who are less technical, product managers can use, so because they're on the other end of the value chain. Because it's like the platform has to basically reflect the multidisciplinary nature of teams that build and deliver quality ML products. It's like probably even more diverse than regular software products. And so having different team members that can come into the platform and then figure out how things are working, why things are working, and how they can all opine and improve the system is of value.
So for an ML engineer who doesn't necessarily see why it's valuable for like their project manager or some of the executives to be able to come in and understand and work in the platform, like, what would you say to them? What's the reason why they should value that?
Well, because I think if you as an individual kind of working in a team, you all want to row in the same direction, and you want to understand what is the overall goal that you're all trying to achieve, and having like the same communication language is very important. And so if there's silos around a non-technical person who is responsible for handling customer, if that individual is not capable of interfacing with you as an engineer because you don't speak the same language, and you can't like dig into the tool and try and figure out how you might integrate customer feedback into a way the engineer understands, then you're not really rowing in the same direction. You're just going to be like less effective as a team. That would be like the intuitive thing, I would say.
Yeah, one thing I found is that a lot of times if you're teaching the product managers and the people that are working with you like how to use these tools, a lot of the like smaller requests, a lot of the things that might disrupt your time or take away from the things you're trying to do, they can effectively self-serve, and it can actually create people that understand what you're trying to do a lot better.
Yeah, this is true. I mean, an example I saw recently is in the data quality space. Is somebody who works on the product side or with customers that's taking the output of some model and then using it to make a business decision or like serving a customer is going to have a very good sense over like, is there something wonky with this data? And they need to be able to communicate that to the edge team that is responsible for handling the data at the source and doing whatever transformations with it, training a model, etc. Because that individual on the edge side might not see the customer side, and so like working on it as a multidisciplinary team means that again, like you can get right into what the problem is and fix it in a way that you're not trying to kind of throw stuff over the fence.
Yep. And what do you see as the role of AI itself within someone's MLOps platform?
like how could you use ML within an MLOps platform?
Yeah, or
Well, I
is
guess
is that a place you should?
Yeah. I think yes, to some degree, and I'd probably cite the data quality example again, because in a way you only want high quality data in your data platform that's being used to train models, and so you can already think about filtering. For example, in AVs, like I don't know how much data these cars generate, but like way too much to even store over a decent amount of time. And so filtering through that data and figuring out like, what should I keep? What should I throw away? That's a perfect machine learning problem. And then like trying to figure out what additional data point might I need based on the performance of the system that I have in production in order to improve performance on that particular class label. It's also a machine learning problem. So I think in that sense, like focusing on some of the rate limiting steps is of value. And then I think the second bit is actually in the annotation flow itself. I mean, you can think about it as interplay between some human experts. Maybe a model can do a model-based annotation at the start, and then a human corrects it. Maybe there are other people or models that you might want to pass data through, like first OCR it and then read the text and etc. So I think focusing on the modular nature of these labeling flows and where can you inject a model instead of a person is another way that machine learning can be useful in a MLOps platform.
Yeah, it sounds like the idea behind like amplifying humans, like using ML to take something that humans are doing and make it have a significantly larger impact is really powerful.
Yeah, exactly. I mean, for example, just focusing on where is there something interesting in an image, like instead of having a human like spend time parsing through that, you can have a model parse through that, or basic object recognition, segmentation, etc.
Okay. So like data deserts is a topic that comes up a lot in biomedical AI research, and is likely a cause of a lot of bias when these models are used in clinical settings. Can you define like what is a data desert and what should people take away from it?
Yeah, so basically a data desert, it reflects a situation where your model is being trained on a data set that just does not represent the entirety of like, for example, the population that you want your model to serve. So best example is maybe biomedical data about patients who have cancer, for example. If you're trying to build a system that can work across the entire United States, but your data set is only representative of people from California and people who live in New York, then you're missing like the vast majority of the US population, and therefore you're training your model on a too small subset, and therefore it's called a desert. And this notion is becoming more and more prescient, because now we're starting to see like a bunch of companies develop imaging processing technologies and applying to the FDA for FDA clearance, and then applying for Medicare for reimbursement. And if we want to scale the impact of these models across different jurisdictions, like, this stuff's really important. And so to illustrate it, there was a study out of Stanford that looked at 56 different papers published over a kind of 5-year window from 15 to 2019 that made use of a deep learning algorithm to basically distinguish one of several elements in an image. And what they found was, in these studies, 71% of them used the patient cohort from only one of 3 states, and 34 states didn't contribute any data. That's like one example. And then there's another example which looked more at like gene expression data sets, and they found significant lack of certain ethnicities and certain overrepresentation of sex or age. And then that obviously causes problems, because it's huge human diversity that these models are not trained to process and learn from.
So how can people identify if the problem that they're trying to tackle is part of a data desert or not?
There, it's mostly about like having rigorous evaluation sort of practices, so that you're not just like doing test and train on a very similar data set, but you're looking at out of distribution samples. You're looking at again, in medicine, like if I have a system that works well in the UK, can I get access to a data set in Germany or other countries? So it's all about just falling into the general notion of like robustness and generalizability. And if there's a lack of generalizability, it could be because of a data desert.
Awesome. So AR and VR is an area that a lot of people have been working on for a while. And like last year in your State of AR report, you predicted that Facebook would make a major breakthrough with respect to 3D computer vision. That really didn't happen. What does that say about the state of computer vision for AR VR? Was this specific to Facebook, or is this kind of point to some broader challenges?
Yeah, it didn't really come out with anything that we thought fit the bill. I mean, they had their workplace kind of VR experience, but we didn't feel that really cut it. I mean, to me, it seems like most of the like AR VR computer vision is done largely by gaming companies like Niantic with their Pokemon Go experiences and trying to like learn 3D point clouds of the world and compute depth so you can kind of render these 3D characters and in a better way for players. But I suspect with now Meta's huge investment dedicated to quote unquote metaverse, and I know they're building teams in vision for these kinds of use cases, and they have their glasses product, etc. So it seems like now there's like a proper motivation to try and crack some of these problems. And I would also imagine that like separately in the politics section, we profiled how Microsoft had this enormous contract with the DoD for selling HoloLens, and I can imagine a lot of use cases around 3D vision for basically troops in the battlefield that they might be working on. So I guess if this metaverse thing pans out, then we're likely to see a lot more 3D vision applications.
And why is like computer vision for AR and VR such a challenging field? Is there something intrinsic about the problem?
Could be. I mean, I guess certain things come to mind is like the world is just a rapidly changing place that's just like really complicated to represent, and I just don't know if we have like the best training data sets for this. Like even learning things like kind of intuitive physics from video is still like incredibly hard. And then to some degree, because AR and VR is almost by definition like an edge application, then you don't have like unlimited power and compute budgets, and you need something to be super snappy, real time, and you're sort of competing with somebody's eyes. And so people are very good at noticing these like subtle discrepancies between reality and something virtual. So if it's not anything less than excellent, then it's not good enough. I'd say probably some of those things come to mind as to why it might be challenging. But I'm sure there's a bunch of much more deeply technical reasons why that probably beyond my pay grade.
Yeah, anytime you have computers interacting with the real world, the long tail of edge cases tends to be really fun and really challenging.
Explosively complex, yeah.
So one thing for everyone listening, if you do have questions, please put them in the chat, and we'll get them added in to what we're talking about. So in the report, you talk about AI safety and that it's really top of mind right now, but fewer than 50 researchers are really working in the domain full time at kind of major AI labs. And within AI safety, AI alignment is like the critical field of research exploring how we can ensure that AI systems have goals that are aligned with what their researchers are trying to work on. And in this field, there's across 7 leading organizations, there's less than 100 researchers working on this problem, which is really a tiny fraction of the AI community. If this transformational AI might happen in the next 30 years, like, are too few researchers actively focusing on making sure it goes well for everyone?
It's a good question. That's exactly the one that we wanted to provoke with the report. Not necessarily saying that it has to be a specific number or a specific percentage. It's more just the increasing number of researchers like feel that that we should prioritize AI safety, and then that we should do probably something proactive about it. And so we looked at a survey back in 2016 that asked AI researchers how they felt about the importance of AI safety, and it's about 49% that thought it should be a priority. And then now it's about 68%. It's across like 524 researchers published in major conference venues. And it is difficult to pin down the exact number because certain teams kind of call their employees slightly differently in this kind of domain. But we just think that if there is a non-zero probability that, as you say, transformational AI can happen, it sort of feels that this number of 100 researchers is probably too small. And we also break out alignment from safety because alignment is like much more of this kind of long-term endeavor, and safety is in a way perhaps a bit more short-term and can be potentially like bundled with generalizability, robustness, etc. And it's slightly more actionable for more teams to think about.
So, like, what are researchers kind of thinking about in terms of AI safety? Are they coming to the problem from like test-driven AI or uncovering edge cases, or are there more novel strategies that people are developing?
Yeah, there's some of this. There's interpretability work that's also happening, and then there's to some degree some of the more like kind of philosophical and ethical points around like, are there certain things that we should try not to develop, or certain ways that we could like limit distribution of technical capabilities, and then there's to some degree like how to inject like values and sort of like decision-making principles to autonomous systems. But yeah, like what's kind of fascinating with this discipline is that it touches philosophy, ethics, law, machine learning, math, policy, etc. So it's a real potpourri of challenging domains that has to come together to figure out like what is pragmatic and what can be like actionable by the rest of the community.
I mean, something I've been thinking about around AI safety is how important is it for people to know when they're interacting with the output of a model, or even which model they're interacting with?
Yeah. I think that it's almost a question of how do you build trust with a user of a digital system in a way, and potentially in a way that I don't know how scalable, how realistic it is to implement something like that, given how broadly applied machine learning systems are. I'm just imagining like a call center that says that you're recorded for training purposes, or it's like your clicks on this website are used for machine learning training purposes. But in a way, like for sensitive domains, probably over communication or being transparent just builds more trust than users figuring out through the back door that something's happening that they didn't expect.
And if a company wants to invest in AI safety and AI alignment and help move the field along, what's important for them to know and get right from the beginning?
I think to some degree, because it's such a long-term discipline or a long-term kind of trajectory, I think having those kinds of teams not be on like commercial deadlines and not be under like commercial pressure, really engaging with this community, because it is very, very small and tight knit. And also to some degree, I think building in the open is super important. A lot of great work that various researchers have done over the years that we tried to profile in last year's report and in this one.
Awesome. Yeah. So a couple questions from the audience coming in for data pipelines and kind of data flow tools. Do you see any trends or winners emerging?
I don't have a super good answer on that, to be honest. Yeah, I don't. Pass.
So nothing at this time.
Yeah, I don't have nothing.
So are folks working on better ways to anonymize or pseudo-anonymize data going into models?
Yeah, I mean, I can opine on this one. Yeah, I mean, like this overall just handles the question of like privacy and can you compute on private data. It's been I think a really hot domain in academia, and then in more kind of fringe applications in companies. So there's like, the federated learning kind of setting where you send the model to where the data lives and train there. And then you have, as mentioned here, pseudonymization or hashing of certain data points. There's also like kind of training a generative model on a data set and then using it as a source of synthetic data that represents the same probability distribution. And then there's a little bit on like homomorphic encryption kind of methods, like how can you compute unencrypted data. I think overall, all these are like extremely exciting techniques that I think are still pretty nascent with like what industry problems are they relevant for. The two that kind of pop out is one, ad tech, like in a post-cookie world. How do you serve like relevant ads to people that you can't track all over the place? And there's been some pretty cool work through Chrome and Brave running FL in the browser. And then the second kind of domain is on life sciences and how can you share patient data across boundaries. And there's been some cool work from OpenMind and a few academic centers trying to build a federated radiology software solution. Because in theory, like medical systems would be amazing if we managed to, like assimilate or aggregate data from a physician in the US and a physician in Europe, like that would be like a super physician. And so, so it seems like FL is like a good way to get there. I'd say like still fairly early days, like industry wise.
Yeah, it kind of seems like going back to the data desert discussion that there are some pockets of ML where federated learning is almost a mandatory before you could see real gains there.
Yeah. And the other thing I asked myself too is like, what is the best company that owns this, and what is the best way to distribute these capabilities? And because like FL in a way is almost like edge computing, kind of, you can think of it. So in that sense, like the best owner of it is probably the browser or the operating system. Than it is like a third-party company that needs to run across all these different devices. So I think kind of jury's still out as to whether an Apple or Google or Brave or something like this is the fastest to implement like a commercially relevant FL solution.
And kind of given all the different types of ML people are doing, are there certain input data types or problem domains where FL has been working significantly better?
I mean, certainly like non-real-time applications, I'd say. But like it started basically in text. I think Google's team in Seattle was one of the first to sort of demonstrate federated learning, and they picked like the Gboard application of parsing people's writing style and then learning specific models based on how they write, etc. And then next step was largely images. Because of the motivation in medical imaging. I haven't seen FL on like speech yet, but maybe I haven't looked hard enough. But who knows? I mean, this stuff like evolves so quickly. FL is like another one where the publication count kind of is going through the roof.
And I guess, is there any library or FL framework that you've been following or seeing people really latch onto?
I would say OpenMind. Probably is the most popular privacy-preserving ML ecosystem.
So with the bit of time we have left, if you were going to impress like one big takeaway for everyone to spend time focusing on and reading about and working with, like what would that be?
I mean, my pet favorite would be like machine learning in biology. I think it's going to be. It's potentially a little bit hard to understand because you might need a bunch of kind of background knowledge to this stuff, but I think like the surface area for how ML can help everything from just analyzing data in a better way to designing experiments to kind of treating biology as a simulatable problem, as we see with things like AlphaFold and the RNA version of AlphaFold. That I think there's a huge opportunity for folks in software engineering and machine learning who might be looking for a new problem to become increasingly effective at driving like some real value across the world in the form of medical innovations that like can genuinely be unlocked with machine learning.
Yeah, I guess it always goes back to the hard sciences and things that are really, really interesting right now.
Yeah, I mean, I want to say it's going to probably be some kind of golden era for this because, we've all just lived through a huge boom of consumer internet and marketplaces, and I think many of the people I meet in those companies are now looking for something like more impactful that they'd like to work on, whether it's climate or biology or. So I think those kinds of scientific domains are going to be like a huge beneficiary of this massive talent move from software 1.0 to software 2.0, as it were.
Awesome. Yeah, and my own parents work in and around biomedical and in the medical industry, and I will say that the previous big revolution of computer vision and imaging and non-invasive imaging did have a fairly massive change in how people interacted with it. Yeah,
for sure. It's about like democratizing care and giving much better care than what we have today. So I think we just have a lot of potential and a lot of like societal necessity to take a good stab at this. So yeah, that's probably what I would impress and what I'm most excited about.
Awesome. Well, I want to thank you so much for jumping on and talking with us today. Really appreciate it, and definitely learned a lot about AI and how you're kind of thinking about the problems.
Yeah, pleasure. It was really fun. Thanks a lot.
Awesome. Have a great day.
Take care, guys. Bye-bye.